Alright class, today we're going to learn about the different wave properties, characteristics of waves. You see the picture on the left? What did one ocean say to the other? Nothing. Just waved. Alright, so what is a wave actually? A wave is a disturbance. A disturbance is when you have a transfer of energy essentially, and it travels through a medium from one location to another. Now, waves are the motion of that disturbance. It's a visual representation of what's happening. And again, waves are a transfer of energy. There are two different main types of waves. One is called a longitudinal wave. So here I have a slinky on the top. Let's say I took my slinky, I push it to the left, and then I let it go. If you do that, you're going to see a pulse of sections that are far apart and then sections that are packed in, far apart, packed in, and so on. You notice in this case the medium, which is the slinky, will vibrate parallel to the motion. Again, I pull it left and right, the slinky will move left and right. And this is what we use to transfer sound. Sound waves project outward as a longitudinal wave. If you look at a tuning fork, for instance, and then you dip the fork into like a beaker of water, the water will vibrate in little ripples that will go outward. Okay, we're going to have some students explain a few of the next slides.
A second type of wave is a transverse wave. We said in a longitudinal wave, the pulse travels in a direction parallel to the disturbance. In a transverse wave, the pulse travels perpendicular to the disturbance.
Good. So in this case, we have the wave moving up and down. If I took a slinky and literally move my hand up and down, you're going to get a transverse wave because the slinky will appear to move to the right, but each individual particle will move up and down. This shows a visual representation of the differences between longitudinal and transverse. If you look at your longitudinal wave, if I move left and right, the coil will move left and right. Energy is in the same direction. Transverse wave, again, up and down. The slinky will go left and right. Perpendicular 90 degrees. Okay, here are the characteristics of the wave. This is a transverse wave to see the characteristics easiest. First is the amplitude. Amplitude is the height of the wave, and that has to do with the amount of energy it has. So imagine dropping a big boulder in a puddle of water. I'm going to get a really big amplitude, right? If I drop a little pebble, the amplitude will be small. The tops of the waves are called crests. The bottom of the wave is called a trough. And then if I go between a crest to another crest, or a trough to another trough, I get the wavelength. That's the distance between waves. Also, we can look at the frequency of a wave. A frequency is how many waves I get per second, okay? So suppose I wiggle a slinky back and forth, and I get 6 waves in 2 seconds. To find the wavelength, you're just going to do the 6 waves divided by the 2 seconds. Each second I will get, on average, 3 waves. The unit for frequency is hertz. The way to remember that is if you frequently hit yourself, it's going to hurt. Bad joke, I know. But that was named after the scientist Hertz, who came up with the frequency unit. The period of the wave is indirectly related to the frequency. So the period is the amount of time it takes to get one full wave. All right? Yeah, it's called the reciprocal of the frequency. Use the letter T for period. So for instance, from the previous example, I had 3 for my frequency. If I want to find the period, all you do is 1 divided by the frequency. So that'll be 0.33. Your unit for period is time, so it's in seconds. All right, how do waves interact? All you'll have to discover is how the waves interact with one another. When they travel on the exact same medium, it's called interference. Imagine if I have 2 puddles of water, and then you make a ripple on each. So say there's a rock that falls on each one. When those ripples eventually collide together, you're going to get interference right here, right? That's where they collide. Two main types of interference. One is called constructive. Think about if you're a construction worker. That means you're building stuff, right? You're getting bigger. In constructive interference, I have two waves that meet up at the exact same places. When you put them together, you're going to get an even bigger wave, right? Think about building. So the way to figure out the new wave, you add together the amplitudes. The amplitudes will tell you how big the wave is. Again, it's called constructive interference. So before interference, I have this red and blue wave coming towards each other. During the collision, the green wave is what you'll see. Just imagine you're in the swimming pool, you see one person do the cannonball on one side, another person does a cannonball on the other, you're going to get a bigger ripple in the middle, right? The other type of interference you could get is called destructive interference. Think about that same house that you constructed and built, and you break it up and you destroy it. It's going to be smaller in this case, right? So let's have the opposite. Two waves are moving towards each other. One is positive and one's negative. What's going to happen? We're going to still add them together, but the direction matters. So if I have a positive on the left and a negative on the right, you essentially add the positive to the negative and then you subtract. During interference, you would get exactly nothing in this case, right? Because they're equal amplitudes. What if my amplitude is smaller positive, bigger negative? My interference will be a little bit negative, right? And then after the interference occurs, the waves will be in the same direction as they were before. So here I have the waves. At which point will we have constructive interference? Constructive is when you have the waves that are bigger because they added together. At what point are they destructive? That's where they cancel out. So you have essentially zeros, and so on. Class, so that covers all the general wave properties. We're going to have other YouTube videos on sound waves, light waves, reflection, and refraction. So feel free to look at the physics playlist. If there's any other questions, leave a comment down below or just shoot me a message at kaminskil@hayescisd.net. Make some waves.